Hello again. Still working with operations of functions, and this time we're going to do composition of functions. It's a little difficult for students at first to buy into or actually do properly, but once they get the hang of it, it's not that bad. With that in mind, we're going to go ahead and try a problem with the composition of functions. It's usually notated like this, but I actually like when I write it like this, it just seems less confusing to me. I don't know what your preference is. It's f of g of x. I like it like that. And we're going to use the same functions we already did for f of x and g of x. I mean, if you want to spice it up a little bit, you can do g of f of x, but I'm not going to spice it up. I'm just going to leave it as it is. So here we go. I want to find f of g of x, and basically if I plug in a value or substitute a value into g, it's going to give me a value, and then I'm going to take that value, I'm going to substitute it into f, and it's going to give me a value, which is actually pretty interesting in its own case. We're not going to do that initially. We're going to actually kind of prove it and then put in the value later. See how that goes. So f of g of x, well, g of x is 4x plus 5. So it's actually going to be, let me say that again, g of x is the same thing as 4x plus 5. So it's actually going to be f of 4x plus 5. Now, that's kind of unusual for students to think about, but let me say this right now. If it said f of 3, all you would do is put in a 3 for every x that you see. If it says f of 4x plus 5, all you do is put in a 4x plus 5 for every x that you see. It's a little bit more complicated though. So I do see an x, but I see an x squared. So for the x, I'm going to put in 4x plus 5. And I'm going to square it, because it's 4x plus 5 squared. Then I've got negative 3. There's no x there, so you can write negative 3. But then it has an x. But for every x I see, I better put in a 4x plus 5. Now when you're substituting values, general rule of thumb to make it easier is just put it in parentheses. Probably disappearing on that side, so I'll go ahead and do that. And then I got plus 1, so you just write plus 1. Now, I'm not going to write f of 4x plus 5, not because I don't want to, but because I need more room to kind of work with. So that's what I want to do. So I'm going to write 4x plus 5 squared. I'm not going to write this part until later. So I've got 4x plus 5 squared, which is the same thing as 4x plus 5 times 4x plus 5. I'm going to go ahead and distribute that negative 3 right now. So negative, that's not right. Negative 3 times 4x is negative 12x. Negative 3 times 5 is negative 15. I got plus 1 left over. Now I'm going to go ahead and distribute, double distribute or FOIL, depending on what you like to say. 4x times 4x is 16x squared. 4x times 5 is 20x. 5 times 4x is another 20x. 5 times 5 is 25. Minus 12x. Minus 15 plus 1. Now what I'm going to do is I'm going to combine like terms. 16x squared, there's only one x squared, so I got 20x plus 20x minus 12x, that's 40x minus 12x, which is 28x. And then I got 25 minus 15 plus 1, which is 11. So basically, f of 4x plus 5, when I did that composition function, is 16x squared plus 28x plus 11. Now, you're not going to generally do a composition of functions in most of your problems in the book, most likely. What you're going to do is be given a value instead in a composition, and g of 2 is blah blah blah, and then f of that is something. Well, that's what we're going to do here, and as long as my math was correct, the answers should come out the same. That's the point of good mathematics. So what I want to do is I want to do a composition function. I want to do f of g of something. And I'm going to pick a nice number because I don't want to sit there and calculate it forever. I'm going to do 2. So f of g of 2, yeah, no, there we go. Should be 2 parentheses. What I want to do is I want to substitute in 2 for the g value, etc. Now the way that I used to do this to make it easier for me to remember was take care of what's on the inside, then work on the outside. So that's what I'm going to do. I'm going to find g of 2. So I got to plug in a 2 for this g. So g of 2 is equal to 4 times 2, which is 8. 8 plus 5 is 13. So let me repeat that again. All I do is I do my g of 2. So that's g of 2. So for every x I see, I put in a 2. 4 times 2 is 8. 8 plus 5 is 13. So actually, this g of 2 is 13. So I'm going to find f of 13. Well, all I have to do is substitute in a 13 into this problem. Because now it's asking, well, if I put in 13 for x, what's f of 13? So this one I'm actually going to write out because it takes a lot more time to think about. So I'm going to put in 13 squared minus 3 times 13 plus 1. 13 squared is 169, I know that one. Minus 3 times 13 is 39 plus 1. 169 minus 39 is 130. 130 plus 1 is 131. So basically, my answer, if I substitute in a 2, is 131. Now, if my math is correct, if I put in a 2 into this x value, I should get a 131. And now, somebody says, well, why? Well, I did the same thing, but instead of plugging in a number, I plugged in the actual function, so the answer should still come out the same. This one just took a lot more work. And hopefully, like I said, if my math is correct, it's going to work out. So I'm going to put in 2 for every x value I see, and I should get 131. I did the same thing, except I actually put in the function instead of the value of the function. So that's 2 squared, which is 4. So it's 16 times 4 plus 28 times 4 plus 11. 16 times 4 is 64 plus 28. Ooh, I got a little ahead of myself. Okay, let me explain that. 2 squared is 4. X is still 2. I just wasn't paying attention. 28 times 2 is 56 plus 11. 64 plus 56 is 110 plus another 10, which is 120. 120 plus 11 is 131. Woo! I knew it was going to be right. Of course I knew it was going to be right, because as long as you do the math correctly and you don't make a mistake like that right there, your math is going to come out fine. So, whew, at least that proves that that one and that one are the same. And it's 2 different approaches. Sometimes you'll be given a problem where it'll say just substituting the actual function, and sometimes it'll say, well, given this value, figure out what it is. So, it's pretty cool. It's operation of functions, and this one's generally the most difficult for students, but once you get the hang of it, that's not too bad. Okay. That said, I hope that was helpful. Have a nice day.